What we're going to do in this video is talk about different population growth strategies for different species and think about if we can come up with a broad categorization or if there's a broad categorization already out there for us. So we see that there are species like elephants that are long-lived. In the wild, an African elephant can live roughly as long as a human being can, 50, 60, 70, in some cases 80 years. You also have things like killer whales that are also long-lived. You have things like human beings that live a pretty good long time compared to other things in nature. You have things like gorillas that are also reasonably long-lived, live many, many, many decades. Now, there's also other patterns that you see on these large mammals. They tend to be large. Especially if you think about compared to very small things in the animal kingdom, they tend to not have a lot of children every reproductive event, I guess you could say it, every time they give birth. So few children at a time. And it takes them a while to give birth to those children, and then they take care of them for a while. Now, at the other end of the spectrum, you have some of the things that we have here. You have amphibians like frogs. You have insects. You could imagine small fish, bacteria, mosquitoes that are more short-lived. They tend to be smaller. And they tend to have a lot of children at a time. So lots of children at a time. Just an example, a frog, or what you see here is this is spiders coming out of an egg sac. Frogs or spiders, they can lay, in many cases, thousands of eggs at a time. And they're not really dependent on any one of those eggs necessarily surviving. Many of them will be killed off by predators, but as long as a few survive, then the next generation, you can imagine, they get to reproduction, and then they'll lay thousands of eggs, and they're shorter lived. A frog could live a few years. Some insects might live anywhere from a few days to a few years. You have things like bacteria that can have an even shorter lifespan. So when biologists or ecologists look at this, they say it looks like there is a spectrum over here. You have these large, long-lived animals that have a few children at a time, and really the limiting factor on their population is how dense their population is. At some point, these animals are going to compete for resources with each other, and that's true of things like human beings. At the other end, you have these things like spiders or frogs. Instead, they might be limited on their reproduction by environmental factors like how moist or dry it is, how hot or cold it is. And so generally speaking, folks have attempted to classify these types of species. They call them K-selected. I'll talk about where the K comes from in a second. And they talk about these types of species as R-selected. And where these letters come from is that there's a general idea that if we draw a little axis here, time, and then draw an axis here, population on the vertical axis, most species that when there's not a lot of them and they're not limited by resources, they will grow exponentially like this. Now, when you go into the math of it, that rate of growth is usually denoted by the letter R, and you could see where this R selected is coming from. And what that R is, how large it is determined by a species' biotic potential. And biotic potential just means in a given environment, how quickly can they reproduce, what percentage of those are able to get to maturity so that they can reproduce, et cetera, et cetera. And so you can imagine the higher the R, the faster this exponential growth goes up. Now, at some point, you're going to be resource constrained. And there's some carrying capacity. And so let's say this is the carrying capacity here, and let's call that K. And the reason why we use K instead of C is K comes from a word for capacity in German. So at some point, you're gonna have so many things that you're just not gonna have enough resources to support more, and so your population would flatten out, something like this. And so generally speaking, biologists have categorized these left categories of species as K-selected. They are the amount that you have, the amount of population is going to be determined by the resources that are there, the carrying capacity in the environment, while things like frogs and mosquitoes and bacteria and spiders you view more as R-selected. They're going to grow exponentially at their biotic potential, but that biotic potential is going to be determined by how hot or cold or wet or dry or other environmental factors. They're not going to get to such a high density that they are really competing with each other. Now, as you can imagine, with most categorizations, nature is not that clean that things are always going to be on the left side or always going to be on the right side. For example, things like turtles lay a lot of eggs, but they live a very long time. It's also worth noting that there's no value judgment that one strategy is better than the other. They've both been successful. The fact that these species exist today show that they have worked well. It is worth noting that invasive species tend to be more R-selected. They will just grow and grow and grow and going to be limited by the environment and not as much by each other, while K-selected species are often the ones that are most affected by invasive species. Now, the last thing I want to highlight is what we just talked about is population growth strategies, and that can sometimes be confused with niche strategies, where are there certain species that are generalists that can occupy many different niches, while there's certain species that are more specialists. Here we're just talking about, generally speaking, how do species tend to grow in population? While when we talk about niche strategies, we're going to talk about the types of niches they fill in order to get their resources. And we'll talk more about all of that in future videos.